Hey everyone, my name is Thomas, and today I just want to talk about something that no one else has made a video about, and it's honestly kind of shocking to me. So if you look here on the title of this, it's named Modernizing Reddit's Comment Backend Infrastructure, written by Katie Shannon. So this article is all about how Reddit transformed from a monolith legacy Python service into domain-specific Go microservices. And I'm excited to go over this article with you all here today. So background, at Reddit, we have four core models that power pretty much all cases: comments, accounts, posts, and subreddits. These four models were being served out of a legacy Python service, which, by the way, in 2025, this is an amazing feat in of itself. They're probably throwing in a lot of money to power these Python backend services, but I digress, with ownership split across different teams. So by 2024, the legacy Python service had a history of reliability and performance issues. Ownership and maintenance of the service had become cumbersome for all involved teams. Due to this, we decided to move forward into modern domain-specific Go microservices. So not only was this thing having just issues in general, but they were having people issues and team orchestration issues where if something went wrong, they had to include many people in the room to make a decision. This is a recipe for disaster, especially at scale, as things start to really get fragmented and start to slow down as you get more and more PR reviewers. I can imagine a code owner's on a pull request on something like a comment is going to have like 30 people, right? And they want to get away from this problem. So in the second half of 2024, we move forward with fully migrating the comment model first. Redditors love to share their opinions in the comments. Nice. So naturally, the comment model is our largest and highest write throughput model, making it a compelling candidate for our first migration. I love that they actually just ate the frog here and said, screw it, we're going to go with the most highest throughput, because if we can do that, that means we can do other ones as well. Great and inspiring to see. How? Migrating read endpoints is typically well understood and the solution is straightforward. That actually feels like a direct call out to me because I've done read endpoints before that were not so straightforward, but it depends on what's happening underneath. We utilize tap compare testing. Tap compare is a way to ensure that a new endpoint is returning the same response as the old endpoint without risking user impact. We simply direct a small amount of traffic to the new endpoint. We get the response generated by the new endpoint, then call the old endpoint from the new endpoint and compare and log the responses. We still return the response back from the old endpoint to the user to ensure no user impact, and have logs captured if the new endpoint would have returned something different. Easy and safe. So this is an interesting point. They say easy and safe. I've personally never had to think about the scale of Reddit. Everything that I've ever done has been B2B and very slow, less than 500 clients. I've made a few million per month or whatever, right? And in this realm, you could easily take down a production application on the off hours, especially if you're in something like the US market. And you can just say, hey, we have a maintenance window and we're going to take this down. You're going to come back up and everything's going to be much faster. So on the other hand, write endpoints are a much riskier migration, of course. Why? Firstly, write endpoints almost always require writing data to data stores, caches, databases, etc. We have a few comment data stores to worry about, and we also generate CDC events. By the way, those that aren't familiar, CDC is change data capture. That's where if certain amount of data is changed or certain shape of it is, or maybe a field is updated, then there is a notification sent out typically to like a bus that has a bunch of subscribers. When anything changes on any core model, we provide a 100% guarantee of delivery of these change events, which other critical services at Reddit consume. So I want to ensure there is no gap, delays, or issues in our eventing generation. Yeah, so imagine there's a consuming service from one of those CDC events, and it's so instrumental to have that CDC event be received to be able to do something with it. And I bet you a lot of Reddit uses these CDC events to power many of their features. It's basically a delegated way not to have to touch the core data models, whereas you can still be streamed those updates on them. So it's pretty neat that they have an event-driven system underneath the hood. Essentially, instead of just returning some comment data like in our read migration, our comments infrastructure has three distinct data stores that are written to that factor into the migration. So they are using Postgres. So that's a backend data store which holds all the comment data. They use Memcache for their caching layer, and they actually use Redis, which is kind of a Memcache alternative, but that event store is used to fire off CDC events, so they do use it as that stream. If we simply tap compare a write migration without any special consideration for the data store, we could get into a state where the new implementation is writing invalid data, which fails to be read by the old implementation. To safely migrate Reddit's most critical data, we cannot rely on validating the tap compare differences with our production data stores. Of course not. They're saying that they can't just simply hope that it works because there may be so many types of events. It's really hard to determine every single way that this shape of data can look like without doing extensive testing. Due to unique key restrictions and common IDs, duplicating writing to our data store is impossible. So how does one validate a write to our data storage from two implementations without committing the same data twice? Well, you can't, right? Thus, in order to properly test our new write endpoints, we set up 3 new sister data stores to be only used for tap compare testing and only be written by our new Go microservices. That way we can compare the data in our production data stores written by the old endpoint with the data in these sister data stores without the risk of the new endpoint corrupting or overwriting the production data stores. So if we scroll down here, they made a wonderful diagram. Let me just zoom out a little bit here. And here you see tap compare dual writes. They have a Go microservice and they have the Python monolith. So similarly, their Go microservices does call the Python service, but it also writes to a sister data store. And in this case, the sister memcache, the sister Postgres, and the sister event store Redis. And you'll see here it does the exact same thing. And then they're going to tap compare, I guess, how this data is stored and what is sent to the CDC consumers. So to verify these sister writes, we direct a small percentage of traffic to the Go microservice. The Go microservice would call the legacy Python service to perform the production write. The Go microservice would then perform its own write to the sister data stores completely isolated from the production data. I wonder how much all of this cost. And I wonder how much traffic they actually sent to this to get a conclusive image or conclusive picture of what everything looks like. After all the writes were done, we had to verify them. We read from the 3 production data stores that the legacy Python service wrote to and compared them to what we wrote to the 3 sister data stores in the Go microservice. So this is great. I don't see any other way to solve this, like right offhand, and as I'm reading this article, without having to do this duplicative work. And it's interesting to me that the Go microservice called the Python directly, because that just seems natural. And then, of course, they're going to compare how the data landed, like I mentioned before. And they're also going to capture the CDC events downstream. This is very well done. I do wonder how much was put into this testing. Like, I bet so many resources were used to make this happen. Additionally, to combat some serialization issues we ran into early in the migration process, where Python services couldn't deserialize data written by Go services, we verified all tap comparisons in the comment CDC event consumers in the legacy Python service. So in order to ensure that the formats were clear, the consuming CDC service, so the service that receives the events, was used actually for Go and Python so they could deserialize it. Cool, that makes sense to make sure that everything's kosher. In summary, we migrated 3 endpoints that each wrote to 3 different data stores and verified that data across 2 different services, resulting in 18 different tap compares running that required extra time to validate and fix. So outcome and improvements. So finally, after all of this work, all of this comparison, all this testing, the duplicative architecture, what exactly came from the outcome? We are excited to say that after a seamless migration, which once again, they're kind of glossing over how seamless this was because there was so much work and probably so much planning that went into this. With no disruption to Reddit users, all comment endpoints are now being served out of our new Golang microservice. This is insane, guys. And I wonder what the time frame on this was. Like, how long did it take? How many engineering resources were used? And I bet you by the ending of it, how much money was saved on the processing power necessary. This marks a significant milestone as comments are now the first core model fully served outside of our legacy monolith system. That's phenomenal. That is insane. When you're able to fully move a primitive or core data model outside of your legacy app into its own built-out microservice, that is a huge technical feat in of itself. Once again, I applaud the Reddit engineering team for this ingenuity. So the main goal of this project was to get the critical comments and read paths off of the legacy Python service to the modern Go microservice. Got it. So we see here the create common endpoint. This is a huge graph, and huge, by the way, of saying hugely beneficial for them. So if we look here, this basically says 99 out of 100 requests are now benefiting from this. This was the latency they had before, and this is the latency they have now. You can see it's abysmal in comparison. Now, granted, the average Reddit user wouldn't notice this change, but I guarantee you their wallets do. So this graph shows the 99th percentile latency for the endpoint called when creating new comments. Wow. The green represents called handled by the Python monolith, while the yellow represents calls from the Go microservice. And we're going to see this same thing throughout. Once again, the update comment, exact same thing. And then we see the increment comment properties endpoint. Interesting. I guess that's the upvote, effectively. I love how they call it the increment comment properties. The green represents calls handled by the Python monolith, whereas the yellow, once again, is by the Go microservice. Interestingly enough, we do see some spikes here, and the spikes do seem correlated a little bit, but at the end of the day, it's still multitudes faster. What a wonderful technical feat. So what we learned. So this is the section that I always love in these articles is what exactly was learned from this migration. Did you learn something new about your service? Did you learn something new about the language that you'd love to share, etc.? So the comment writes migration, while successful, provided valuable insights, yes, for our future core model migrations. We came across a few interesting issues. And these are the type of issues that you can also take for yourself outside of this, right? So this is what I love reading these articles for. So differences in Go versus Python, of course. Migrating endpoints between two languages is inherently more difficult than, say, a Python to Python migration. Facts. So of course they were going to expect difficulty at the gRPC level, especially with the serialization. And for those that don't know, gRPC is really just like this back-end communication language where you define a function and a signature and you can call these on the back end. And it's a different protocol than, say, something like REST, which is over HTTP. What was unexpected was the underlying differences is how Go and Python communicate with the database layer. That's interesting. Why would that be different? Python uses an ORM to make querying and writing to our Postgres store a bit simpler. We don't use an ORM for our Golang services at Reddit. And some unknown underlying optimization on Python's ORM resulted in some database pressure when we started ramping up our new Go endpoint. Huh. So this is unexpected to me. This is actually a testimonial to an ORM for once. So what they're suggesting here is that a Python ORM, which is an object relationship mapper, whereas it builds the query for you on the back end, you just give it some natural language or some sort of like Python class where it can try to build the SQL query for you and or SQL update. There was some sort of optimization going on behind the scenes that they weren't aware about. And they didn't replicate that optimization when they ported over to Go. They probably just expected it to work similarly. But that ORM actually ended up helping them for the database operations, whereas in the Go endpoint, they noticed that their handcrafted SQL queries were not the same performance. And that's what they're talking about here with that database pressure. And it's also interesting to note they chose not to go with another ORM. They said, screw it, we're just going to stick directly with the SQL language and what it provides us out of the box for Postgres. So that's something that the Go community is huge on. Use the standard library and what comes out of the box with the language. Don't try to inherit an ORM. Don't try to inherit these useless abstractions that just end up weighing you down and forcing you into a corner. So it's interesting that Reddit subscribed to that idea. Luckily, we caught on early and we were able to optimize our queries and Go. Moving forward with future migrations, we've ensured to monitor our database queries and resource utilization. This is interesting. Did they not do this prior to ramping up? So I guess that was the key mistake that they're saying. They were so focused on that serialization and ensuring feature parity that they also didn't take a second glance, or at least enough of a glance, at the database resource utilization. But they're saying that moving forward with the future ones, they're certainly going to put it there. Race conditions on comment updates. Tap compare was a great tool to ensure we didn't introduce differences with the new endpoint. However, we were getting false mismatches in our tap compare logic. We spent a long time trying to understand these differences and ended up being because of a race condition. Naturally. Oh my gosh, the amount of times that I've been screwed over by a race condition or had incorrect testing because of it, either it was self-imposed by myself or it was a true race condition, is such a pain in the ass to try to find out whenever you're doing these things. Let's say we're comparing an update comment call, which updates the comment body text to hello. Then update call gets routed to the new Go service. The Go service updates the comment in the sister data stores, then calls the Python service to handle the real update. It then compares what the Python service wrote to the production database and what Go wrote to the sister database. However, the production database's comment body is now hello again. This caused a mismatch in our tap compare logs, which didn't make much sense. We realized that this was because the comment that was updated had been updated again in the milliseconds it took to call the Python service and make the database calls. So because the secondary service or the Go microservice was much faster, and because it still takes a second to call that other service because it has to route over probably gRPC if I had to guess, that time to go over that caused a mismatch between the two stores only intermittently because of that race condition. Once again, pain in the ass to debug things like that. This made things complicated when trying to ensure that there were no differences between the old and the new endpoint. Was there a difference because of a bug in the implementation between the old and new endpoint, or was it simply an unluckily timed race condition? Moving forward, we will be versioning our database update to ensure we're comparing relevant model updates. Oh, so did they just find out that it was a race condition? Or are they actually admitting that, shrug, hopefully this isn't a bigger problem and our implementation is correct? Because from the sounds of it, they're literally suggesting, or was it simply an unluckily timed race condition? Are they implying they still don't know? That would be insane. Hey man, YOLO 2025, let's go. Let's see how 2026 operates. So onto the test. A lot of this migration was spent manually poring over tap compare logs in production. Feel like this could be automated, to be honest. Moving forward with the future core model migration, we decided to invest more time having more comprehensive local testing before moving forward with the tap compares in hopes that we'll catch more differences in the endpoints and conversions early on. This isn't to say there weren't extensive tests in place for the comments migration, but we'll be taking it to an entirely new level for our next migration. Good to hear. I don't know if it's worth the engineering effort to spin up even like a microservice in of itself to determine and compare these tap logs. But at the end of the day, I guess if you're only going to do this 1 or 2 more times, maybe not, especially if you have some sort of system and process or regimen for it. Each comment is composed of many internal metadata fields to represent different states a comment can be in, resulting in thousands of possible combinations in the way a comment can be represented. This is exactly my point earlier. They had to have the sister data store as well as the primary data store in order to do any of these 1 to n combinations of how a comment can be stored in, because they probably couldn't test everything exhaustively, which is why if they had a certain base, let's say 25 to 40% of the cases covered, it was probably good enough. We had local tests covering common comment use cases, but relied on our tap compare logs to surface differences in the niche and edge cases. Exactly. With future core model migrations, we plan to delve into these edge cases by using real production data to inform our local tests before we even start to tap compare in production. Yeah, I guess. I mean, honestly, if it was successful now, then why would they need to delve into those edge cases sooner? Right? Did they actually, what I'm actually interested in is, did they catch these edge cases after the migration ended? Did they actually see problems downstream from this? Maybe some of those edge cases they didn't ever see or find? I am curious on that. And it's interesting to me that the internal metadata fields to represent different states a comment can be in feels like one of those legacy things where, because you just keep wanting to add to this data model and you don't want to like change any of the core attributes, you add a metadata field for this thing. Then you add a metadata field for this thing. Then you add a metadata field for this service. And before you know it, there's like, it's one of those data models where now there's a million different data fields or internal metadata fields, and you don't know which one is used for what combination of them are used to determine what type of state. And I bet you it's a mess. And that's just without me even being affiliated with Reddit or even understanding their architecture. I can just guess that from right here on sitting on my chair. So what's next? The goal of Reddit's infrastructure organization is to deliver reliability and performance with a modern tech stack, and that involves completely getting rid, of our legacy Python monoliths. As of today, 2 of the 4 core models, comments, and accounts have been fully migrated from our Python monolith, and in progress are the migrations for posts and subreddits. Soon, all the core models will be modernized to ensure your am I the asshole judgments and cute cat pictures are delivered more lively and faster. That is that spunky Reddit humor. So I hope you guys did enjoy this video. I know it was a lot more of me reading and digesting rather than giving my augmented thoughts. But at the end of the day, I haven't had to deal with a migration of this multitude at all. Like I said, I've always been B2B, where I could afford some sort of maintenance window and downtime without much customer complaints. But this was a great article to go over, and if you haven't checked it out, I would recommend you to do so. But hopefully this read was really great for you. I loved going over it. If you want to see more videos like this, please let me know. Thank you so much, guys, for watching, and hope to see you in the next one. Peace.